Good afternoon and welcome to the webinar. Today we'll be talking about how to accelerate, evolve, modernize, and transform with CDW and Red Hat. I'm Kim Johnson with the CDW Solutions and Services Marketing Team. Before we get started, I wanted to mention a few quick housekeeping items. We will save time for Q&A at the end, so if you have questions, please drop those in the chat throughout the presentation and we'll talk through them at the end. And after the webinar, you'll be prompted to complete a short survey. It'll open automatically in your browser, and it's just a few quick questions. If you wouldn't mind doing that, we'd really appreciate your feedback. Our hosts today are Steve Jones, Principal Field Solutions Architect, and Roger Haney, Chief Architect, both in the Office of the CTO at CDW. Take it away, Steve.
Good afternoon, everybody on the call. Happy to have everybody here today. We're going to be talking about the evolution of our data center virtualization and in concert with Red Hat and what Red Hat has been able to accomplish with various tools, open source tools, and what they've developed in the form of Red Hat OpenShift. So our agenda today, we're going to talk a little briefly about the current state of the industry. We're going to talk about what the trends are. We're going to look at Red Hat OpenShift virtualization, and then we're going to actually do a live demonstration in which I have my cohort here, Roger Haney, acting as my data center manager, and we'll demonstrate a live migration of a virtual machine from VMware into and running within the OpenShift environment. While this demonstration is going on, we're going to take a look behind the scenes as to exactly what's going on and why this actually works. A brief Q&A and then a thank you. So a brief history. The entire industry, the virtualization industry, was experiencing upheaval when Broadcom acquired VMware and drastically changed the face of licensing cost and really threw a monkey wrench into people's plans in terms of strategic planning. This really set a fire underneath the next evolution in virtualization and really created a path for moving forward. And Red Hat saw an opening here and jumped onto that. And this really created an environment where we see virtual machines being on their way out. And really the question is, why is this the case? Well, we're seeing businesses that are driving accelerated digital transformation. We're seeing businesses demanding higher developer productivity, increase just operational efficiencies and standardization beyond what we've been able to accomplish in a traditional data center environment. And a lot of that is taking the lessons learned from cloud native deployments into the large cloud providers and wanting to apply that to an on-prem environment. So traditional virtualization platforms really can't deliver well on these demands that the business is sending off to our IT organizations. Kind of the other thing is that the entire movement toward virtualization really paralleled the traditional physical data centers. So it really didn't offer too much in terms of revolutionary IT operations. It was just a small step. So what we're seeing the trend right now as time moves on is we're moving from our legacy virtual machine environments, moving to cloud native type environments. Over time, this is what we're seeing, the transition to be more cloud native type environments. And most organizations are sitting right here on the cusp of this march towards cloud native. In comes Red Hat. They brought in, they saw an opportunity. We have OpenShift, that is a container platform built around Kubernetes. But what was added is virtualization, is running virtual machines within a containerized operating environment, OpenShift. And really, when you look at OpenShift, OpenShift is comprised of a vast number of, or Red Hat's entire portfolio of open source projects. Ones they've incorporated into OpenShift, some they've incorporated into OpenStack. They've included storage technology like Ceph into storage. They made recently an acquisition of Ansible. So now we have an entire automation platform for doing configuration of infrastructure. And just recently, IBM, who owns Red Hat, acquired HashiCorp for around $6.4 billion. So now within this entire kind of, if you think of it as an ecosystem, there is an entire one place to go for a commercial offering for both automation, infrastructure as code, automated configuration, and then an environment that surrounds the concept of this new concept of virtualization called containers. So OpenShift was designed to address these different scenarios: bare metal, the virtual environment, creating private clouds, addressing it in public cloud, or doing edge compute, providing a platform that natively supports these different applications, data, operating systems, an environment that is conducive to not only development tools, but also the automation and the management of these systems, and then providing a very strong partner system that's built around the open source community. And really that's what OpenShift has become, is this new modern application platform that is designed to deliver workloads in a cloud native way of doing things. So why Red Hat OpenShift virtualization? It is the answer to the next generation virtualization. It provides a single platform for not only supporting container-based workloads, but also our traditional virtual machine workloads. It provides a consistent management interface, a consistent API. It's entirely stable. It's well understood, based upon well understood technology that's been around for a long time. Linux, KVM, QEMU. On top of this, it leverages KubeVirt, which is what allows virtual machines to run within the Red Hat OpenShift virtualization environment. And it is a commercially supported environment. It also helps our operations teams in the sense that in this environment, especially for organizations that are heavily dependent upon Red Hat Enterprise Linux, one is entitled to get to unlimited number of guest entitlements of RHEL. It is also supported by Microsoft, so you can run Windows workloads or Windows virtual machines on top of Red Hat OpenShift. It is an entirely integrated system that supports all of the workloads that that we are currently supporting today in our traditional virtual machine environments. So across the board benefits, there is a common management system that supports our operations. It is simple. It allows us to create much simpler overall infrastructure, simpler networking, simpler firewalls, and we'll touch on that in a bit. Simpler load balancing. It allows us to focus less on the details of the infrastructure from a physical standpoint, and really focus our attention on managing this thing as a platform and delivering what the business requires in terms of supporting workloads. It also provides an opportunity for the application developers to focus more on application development leveraging a mixture of containers, serverless, microservices, virtual machines, and less upon how their applications can make use of or have to make use of items within the physical infrastructure like identity management or secure connections, things like that. It also allows a legacy environment of VMware to move the virtual machines over to Red Hat OpenShift, and then on a slower schedule, refactor those VMs or the applications that are managed in the VMs and move them over into more container-based solutions. So now we're going to get to a demonstration of just what is entailed in moving a virtual machine over from a VMware environment to Red Hat OpenShift. And to that end, I'm going to turn this over to Mr. Haney, who will be our data center, our VMware data center manager, and to start on his side.
All right, thanks, Steve. Let me go ahead and grab the screen and bring up my vCenter here where I'm running my virtual machine. And let's go ahead and bring up our console to that machine. And let me go ahead and log in here to the machine. Oh, I have already logged in, never mind. So since I don't trust you, I've only known you for about 30 years now. I'm going to go ahead and create a small file here. And what I'm going to do is I'm going to take the date. So if we look at the date right now, it's Thursday, March 13th at 6 p.m. Universal Coordinated Time. So I'm going to take that date and I'm going to put it into a file I'm just going to call temp. And I'm also going to call on one of our co-panelists here, Lisa, to give me a phrase that neither you or I know, so we can prove this is real time, that we're going to move this virtual machine. So Lisa, you want to give me a phrase?
How about embrace the journey?
Embrace the journey. Okay. I should probably give that an exclamation point because that sounds like it's and then I'm going to add that to our temp file. And then let's just go ahead and look at that temp file. And here we see we have the date and embrace the journey. Okay, so I'm going to go ahead and get out of here, Steve. And I'm going to let you go ahead and transfer that virtual machine over to your system. So I'll stop sharing if you want to take over.
Yeah. So you should now see the console, or should be sharing. I'm sharing. Nope, nope, not yet. Oh. Now I should be sharing.
There we go. Yeah, we see the console now.
So what you should be seeing is what you are seeing here is the main OpenShift web console. So OpenShift sits on top of Kubernetes. Kubernetes is the orchestrator, and Kubernetes basically is a GUI-less orchestrator that is analogous to VMware vCenter. So what you're seeing here is all the different things that you can manage from this GUI console. One thing that we're not going to be paying too much attention to is workloads. Those are containers, but the one that we are paying attention to is this portion, virtualization, and then migration. And migration is what we're using to actually migrate the virtual machine. What I have here, I have two windows. I'm going to move that away over there. The top window is the virtual machine that will be migrated. The bottom window that's blue will be is the current virtual machine as it sits within Roger's environment. And Roger, I'm assuming that this IP address is still is this the right IP address? 154.118, or is that not it?
Yes, it hasn't changed yet.
Okay. So I'm just going to start setting up a ping that goes running right here, and I'll just keep it running. For migrating a virtual machine over, when we go over to the migration section, there's some fairly straightforward pieces of information that end up getting built ahead of time. One is the providers for virtualization. What we have here is we have defined the vCenter server, and given it its IP address. We have credentials that are set to get into vCenter, and that is one provider, and that becomes our source, and it's marked source, and and OpenShift understands that that is a VMware source. And then the other one is the host cluster, and that is the OpenShift cluster itself. So in our providers, we have a source and we have a destination. We then build networking maps. And basically what we're doing here is pretty much the same thing. What network are we coming from? From the one side, VMware vCenter, and what is our target in terms of networking? And so we build that map. And then storage, and this one happens to have two, but in this case, we'll use what's called base storage. We define what the source provider is for the storage, and then what the target is for the host. And what will end up happening when we do a conversion is we're simply taking the virtual machine, and in this case, we're going to find this out as we when we start building what's called a plan, and the plan then takes the provider, maps the networking, maps the storage, and builds a plan to do the conversion. So we're going to create a plan here, and we're going to call this, I don't know, Roger, give me a name.
VM conversion test.
We're going to select the provider, and the source is going to be our -02 vCenter. Our target is the host. We're going to put it into a namespace, and if you're not familiar with Kubernetes, namespaces are what is called projects. If you look in the far left, namespaces are basically ways of corralling containers, and containers they're in pods, but basically it creates a private space. You can't talk between namespaces unless you do some network connectivity. So I already have a namespace called OCP demo, and we're going to put it right there into that namespace. Now, because of our connection to VMware, we already know the names of the data centers. And in this case, this -02 is the data center name, and we're going to select that. And now what OpenShift has done is it's gone out and queried vCenter, and we've got 11 pages of possible targets of VMs. But I think we're already pinging the one that Roger did, so we want to grab that. So Roger, what's the name of that virtual machine you created?
It's RHOS dash convert, I think it is.
Well, I guess we'll find out. Yes, it is. And notice there's a warning. So what he already knows, Red Hat OpenShift knows that in the case of Roger's virtual machine out here, change block tracking is not turned on. What this means is that we're not going to be able to do a migration from VMware to OpenShift while the virtual machine is running. change block tracking can be turned on onto VMware VMs, going through the settings and doing some advanced, it's a line in the configuration, the VMX file that implements change block tracking. Once that's turned on, then virtual machines can be migrated in real time and while they're running. In this case, it's going to end up turning off shutting the VM down, and then it will end up converting the VMDK over to the disk format under OpenShift. So we're going to select this one. We're going to select our network mapping, and that's the base map that we created. And we're going to tell it, we're going to take the target, and we're just going to give it the default target. Storage, we're going to take the base storage. We're going to take the default target storage on our OpenShift cluster. So we're going from the VMware data store to our storage on OpenShift. It's telling us again, this is going to be a cold migration. So the source VM is shut down while everything is being copied over. Change block tracking enabled. We would not have to do this. You do have the option of adding hooks to kick off any configuration items that you want. We're not going to be doing any of that, so we'll go through this. And then we get a review of our plan, and it just gives us a mapping to make sure that we've selected everything. We know we're doing a cold migration. And the plan is ready. Now, what we'll end up doing is we'll click on Start and give it a little bit to start. And what you'll get once it's started, there will be a status page that gives you an idea at every single stage where OpenShift is at each stage of the migration process. Because as I said, and here it started. It takes about 5 minutes for this, so you can see that it's actually doing things. Our ping is still running over here, so we know it hasn't shut down the VM yet. So right now it's initializing everything. I do have let's see. Let's do this. We'll go look at the namespace. And we can see that no virtual machines are there in the namespace yet. Except I'm looking at the wrong one. There we go. Ah, it looks like pings have stopped. So OpenShift has already told vCenter to start shutting down the virtual machine over there. So it looks like we have got lost pings now. So we know that something's going on here. It's starting to allocate disks. So while this is going on, let me switch back over and go through kind of like a refresher course of virtual machines versus containers. So really, there's very little difference between what is going on in terms of virtualization between virtual machines and containers, except we are not recreating the operating system kernel over and over and over again. We're sharing a common operating system kernel. There's a small shim between. And so really all a container is doing is running our workloads with the dependencies that it requires, which makes these containers extremely small in nature, typically. And they only contain those things that are required to run and draw from what's being provided by the OS kernel that's running on top of the hardware. This does limit you to running workloads that are compliant with the operating system that it happens to be running on. So this really kind of begs the question, are containers suitable for running? If I have a container platform that's running on top of Linux like OpenShift does, how can I possibly run Windows virtual machines? And this is really where OpenShift virtualization comes into play. One thing to point out is that when we do implement this new container environment, we really are creating a new paradigm around how our workloads are all provisioned, how they're managed through YAML files. And really, this really ushers in the fact that Kubernetes is really the new vCenter, but without the GUI. And what makes this so powerful is when we get to the concept of deployments, which is the next kind of iteration beyond containers and pods, we're able to then specify things like load balancing, like DNS, like web application firewalls, or just firewalls. And then our description of what our applications require really move with the application rather than building this outside complex infrastructure of firewalls, DNS, load balancers. They're all contained within this construct that Kubernetes enables called deployments. And what that really brings us to is, why is OpenShift virtualization capable of running both any kind of VM, Windows and Linux VMs? And that's because adding KubeVirt to OpenShift, what really happens is KubeVirt creates a container running on top of Red Hat Enterprise Linux. And within that container, it's brought in the dependencies of KVM and KMU. And those two components are really the type 1 and type 2 hypervisors that are built into Linux and have allowed Linux to run as in the same way that ESXi does, and allowed it to run virtual machines. So at that point, within a container, we're running KVM and QEMU. We're then bringing in the virtual machine that has a complete copy of, in this case, it can be a Windows operating system, the dependencies and the application. And that's exactly what's happening within OpenShift virtualization. And that's what allows us to run both containers, regular containers with workloads, and then containers that are running virtual machines. The big plus here is the management paradigm in this scenario is the same, regardless of whether it's a native container or whether it's a virtual machine inside OpenShift virtualization. Logging, metrics, resource constraints, monitoring, it's all the same tooling, the same automation scripting, whether it's Terraform, whether it's Ansible. We're able to leverage the same concepts, and it's all falls underneath the orchestration of Kubernetes. So we'll switch back. Let's see. We'll refresh our screen. And we have a virtual machine. So as you can see here, we have a virtual machine console, very similar to what we have in VMware vCenter. We're able to stop, restart, pause, clone, migrate. Very, very similar to what we can do in vCenter. We have a console. Looks like our virtual machine's booted up. So up here, looks like our virtual machine is live. So Roger, what's the login to your virtual machine there?
Username is Packer.
Hacker 10 30. And your password?
Is -bang098.
098. And there we go. So your file, oh, there's your file. And I think the virtual machine made it over to our OpenShift environment and seems to be the very one that you edited within your VMware environment. What's your verdict?
That's it. That was Lisa's phrase, and that's the correct time.
Cool. So there we have the background behind OpenShift virtualization. We've demonstrated a move over to OpenShift virtualization platform. It's very simple, very straightforward, and very easy. So at this point, are there any questions? Kim, do we have any questions from the audience that people might still be having about this?
Yes, we do, actually. The first one is, isn't the performance of a VM much less on Red Hat OpenShift than on VMware?
At one point, doing this kind of virtualization, there were probably some issues. The biggest addition and what KubeVirt did, and I mentioned this in the slide, they leverage KVM and QEMU. It really provides direct access to or more direct access to the hardware rather than trying to emulate everything. That's a function of KVM being a type 1 hypervisor, which is very similar to ESXi, which is a type 1. So in very real terms, for most VM workloads, there may be some outliers and things that we ran into even in the VMware space, like big databases and stuff like that. But for the most part, the performance is on par with what we've seen in the VMware environment.
Okay, we got another question. What are the memory/CPU requirements of OpenShift versus VMware?
In general, they are largely the same in terms of maybe less memory and CPU requirements than what one would plan for in a VMware environment, depending on the mix between how many containers I'm running and how many VMs. Containers use far less resources than VMs do. But if you're in a situation where what we're recommending is starting to move virtual machine workloads over to OpenShift, then you're going to see very similar CPU and memory consumption like you would in a VMware environment. So our recommendation typically is use the same kind of rule of thumb that one would use in building out a VMware cluster, and use that for the OpenShift. For future down the road, when you become more heavily on the container side, the resources become quite a bit less.
All right, we have one final question. Is
Okay.
managing containers/VMs on OpenShift more complicated than VMware?
That's a good question. It is a paradigm shift. I wouldn't call it more complicated. one of the things that Red Hat is doing through the web console is trying to create a management environment that is um, analogous to what one would find or one would encounter in a vCenter type environment, trying to make sure that it's not a completely foreign management environment. The reason that I say it takes a mind shift is because moving to a container-based and Kubernetes type environment, really, in order to get all of the benefits out of a Kubernetes environment, and make no mistake, that is what OpenShift is built on top of is Kubernetes, is an entire cloud native RESTful API, leveraging, giving the tools to operations to instantiate, manage, decommission through infrastructure as code, and configuration as code, so that you're not just doing point and click like we always have been. So in other words, getting us out of the role of the way we've been managing data centers for most of our lives and getting into the mindset of DevOps, DevSecOps, and what we're now talking to customers about is this area called platform engineering, where we're really treating this as an entire ecosystem where it is treated as a platform with self-service portals, things like that. So it's a vast change, but I wouldn't call it more complex, just because Red Hat has done a fairly decent job of providing a very familiar GUI type management environment. I hope that answers that question.
Yes, and I will do a quick plug for a platform engineering immersion day we have coming up on March 27th. If anybody's interested in getting in the weeds with us, I will be doing that from 10 to 2. You can reach out to me for more information about that. And that's our last question. Steve, thank you so much for your time and your expertise. You as well, Roger. We appreciate it. And thank you for everybody who attended today. Any final words, Steve?
We're here to help. We're here to move people into the next phase of our IT industry, and it is a revolution.
Great. Again, thank you for your time, everybody who attended. We appreciate it. Please let us know how we did today on the post-event survey and reach out to your account rep for more questions. You can also indicate on that survey if you'd like to be contacted for more information. Thank you again. Have a great day.